Hello and welcome to the Oxford University Museum of Natural History. Thank you for joining us tonight, and thank you also to all of you who have so generously donated. It's great to be here. My name is Chris Jarvis, and I'm in charge of the adult programme here at the museum, which this year is going to be focusing really on human and planetary health. So we've got a range of debates and talks, and even an exhibition coming up later in the year for you to tune into. But tonight we're having the second go at a new type of event, an event we're calling Drawn to Nature. So it's an event where we really want to share the inspiration and the well-being and excitement that we get from our specimens. And as you can't come to the museum, we thought we'd bring the museum to you and bring some beautiful specimens to you. So it's not really an art lesson; it's a sort of science and art event. So what we're going to do is we're going to start off with a 20-minute talk from one of the wonderful people that works here in the museum about one of her favourite subjects, just to give you some sort of inspiration and background to tonight's subject. And then we're going to go into several art challenges for you. So we've got some specimens out. Some of them are under microscopes, so little fiddly and very, very small, but hopefully they'll be big for you on the screen. And you're going to get several challenges. First of all, we're going to start off with two quick 2-minute sketches of specimens just to get your eye in, and just to sort of get your creative juices flowing. Then we're going to move on to a specimen for about 4 minutes, another one for 6 minutes or 10 minutes. And then finally, we're going to end up with a nice 15-minute still life extravaganza for you to join on. Now, as I said, this isn't an art lesson. It's really not for teaching art. It's just for you to immerse yourself in some of the wonders of the incredible biodiversity surrounding us, and share some of the excitement we get and gain some creativity from it. So make sure you've got your art materials ready, whatever they might be. And tonight's subject is probably one of the most inspirational, I think, and largest and most diverse of all the families we have of animals on the planet. It's flies tonight. And before you go, flies, there are some beautiful flies, I promise you. And our wonderful speaker tonight is Head of Life Collections, Zoe Simmons. Now, Zoe is Head of all Life Collections here in the museum, but for a long time has been head of our very large Diptera, that's the flies collection, and also our arachnids collection as well. And she's going to give you about 20 minutes of talk on why she loves these things so fantastically, and she really does love them. The care she takes over curating these specimens is incredible. She's also author or co-author of our book here at the museum, Rare and Wonderful: The Treasures of the Natural History Museum as well, which we published in 2018, which has some of her wider interests in. So obviously, we love to know where you're from. We've got some people in, I can see, from Peru, from Germany, from Tunisia, from all over the place. Now, as it is science and art, don't forget to put your questions in the chat bar at the side. And what I'll be doing is collating those questions through the evening. And during our last still life, I'll be putting those questions to Zoe so she can answer them. So without further ado, it gives me great pleasure to introduce Zoe Simmons, our Head of Life Collections here at the museum. Zoe, can you hear me? Hello.
Yes, hi. Hello, everyone. Right, so over to me. This is where I have to work the technology, so just bear with me for a second. This is all new to me, so hopefully, here we go. This is my fabulous first slide. Hopefully you can all see this. So thank you to Chris for the introduction. I do want to start off by saying that this really is just me being enthusiastic at you about a subject that I really love. I'm not going to pretend that I'm an expert on flies. There are people who know a lot more. I'm just going to take you on a kind of crash course through Diptera of all the things that I love best. So just before we get started, though, I'm going to start by scrolling right back up, though, because although insects are ubiquitous, you can find them all over the world, and there are more insect species than anything else, there's still people who don't really know what insects are. So we're going to start at the top a little bit. So we're going to start with animals and then come down, because I'm going to assume you all know what an animal is. And we're going to start with the arthropods. So this, if I can get the clicky thing to work, here we go. Oh, here we go. I have a title, arthropods. So this is one of the biggest groups of animals, if not the biggest, possibly. if I have check. Insects are part of this group, and there's four main groups that I wanted to talk to you about, and hopefully you will recognise most of these. So first up, we have the crustacea, which includes things like crabs and lobsters and shrimp and woodlice as well. We have the spiders, which is the other group that I look after at the museum, another one of my passions. Actually, it's the arachnids, and there are several groups within the arachnids. The true spiders are one of those, but it also includes things like scorpions and ticks and harvestmen, along with several others. There's also the myriapods, which are millipedes and centipedes, but then the biggest group are the insects. So there's about 1.5-ish million described species of animals at present, although that number continues to rise. Over 1 million of those are insects. So 2/3 of all of the forms of life that we have described are insects, which is quite phenomenal when you think about it. And we're just going to be talking about a chunk of these. I'm giving you some of this context because I want you to know why I can't be super specific when it comes to a lot of things, because there's a lot to know basically. Once we get into the insects, I'm going to just set the tone here, okay, for the rest of the talk. So once we're in the insects, what I thought was really important for everybody to know, rather than going into complicated taxonomy or morphology, you know, I can talk about how all of the arthropods have an exoskeleton, so they have an external skeleton, which one of their main characters. They have segmented bodies, they have paired jointed appendages. That's all useful to know, but actually what I think is the most useful thing to know about insects, and certainly the rest of the arthropods, is that they are, certainly for insects mostly, a small, here we go, here's an ant. Hopefully most of you will have seen an ant, which are quite small. Most insects are 5 millimeters or less in size. So the majority of insects are very tiny, and you have to put them under a microscope to be able to do identifications. But of course, they're not all small, because they're smallish. And you get things like this, which is an enormous butterfly, which can have huge wingspans of several centimeters. They are also crunchy. They have an external skeleton. This is a hispine. It's a type of beetle, which do have very hard exoskeletons. You can see all the spikes all over this one. It's really rather nice. And it's one of the defining features of the group, except I say ish again, because then you get things like this. So this is an aphid. They do have an external skeleton, but it's not heavily sclerotized like it is with the coleoptera. So in fact, they're actually rather squishy when you look at them. Mobile is another factor with insects. Here's a nice dragonfly. If you've ever seen them rushing up and down rivers, you'll know that they're very strong flyers and they fly quite quickly. And most insects have the capacity to fly. And I say most because usually they do, but not always. So here we have with female vapor moth. They used to be able to fly back in the day, and they've since evolved. They decided at some point they don't need their wings, and they've evolved the loss of wings. The male still flies and he seeks out the female, but the female doesn't need to move around, so they just have rudimentary wings now. And it's a unit. There we go. One unit, one species. So that's how I want to define insects this evening, though, is a small-ish, crunchy-ish, mobile, usually, unit. And I say all of these ishes and usually because the thing about insects, and I was reminded of this very, very recently, actually, is that there are no absolutes. So I can't tell you a rule for identifying a particular group, because there will always be a species within that will break the rule, and we'll talk about a little bit of that. So all of these things are going to be quite vague. This is this high level stuff. We're going to drill down further as we go through the talk, but I do want you to know there's always the exception with insects, always the exception. If we haven't found it yet, we will soon, basically. Anyway, so we've got insects. We now know them as smallish, crunchy-ish mobile units. I can get the next slide up. Here we go. So here's the insect orders. So within the insects, of those million species, there are between 29 and 32 orders, depending on how you classify them. I'm not going to go into all of that. We're here tonight to talk about one particular order, but I did want to show you some fabulous images. These are all of these are from the collections. These are specimens that we house here. We have about 5 million insect specimens in the museum. And then they told me that I had to pick 4 for tonight's talk. So I'm sure you can imagine my consternation when I discovered this. The different insect orders that you can see up on the screen. Hopefully you'll recognize some of those straight away. We've got the quite recognizable Lepidoptera, for example, that's butterflies. Another big group would be the beetles. So we've got a lovely shiny carabid over here. This is really rather stunning, this specimen, I have to say. There are 5 really big orders of insects, butterflies and moths being one of them, beetles being another. The Hymenoptera are the bees, wasps, ants, and sawflies. You've got the Hemiptera, of which we have not 1 but 2 membracids in this presentation right now. We have this rather little striky, stunning chap down here, and then this oddball up in the corner with this little helicopter hat on. That's a whole other talk. I'm going to move on, but just appreciate how cute he is for a moment. And then the final group, of the 5 of the large orders, is the Diptera, and that's what we're here to talk to you about tonight. So we're going to move on swiftly. So we can see the flies. Here we go. Ta-da! There are between, depending on which source you look at, 110 to 150,000 described species of flies. Within that, there are around 188 families of fly. It's a big group. It's not the biggest. It's one of the biggest, but certainly though. And they are all characterized by a particular set of morphology, which I'm going to go through in a moment. I just really wanted you to see some fun pictures of flies. I've put some of my favorites in here, actually. So you've got some really nice, this little spotty guy up here in the top left corner is a really fantastic fly when you see it up close. It's tiny. This one is about 2 or 3 mil big. So all of these images have been taken using a special photographic technique called photo stacking. So one of the things you will see later when we get to the drawing part is that because insects are small, but they're also quite rotund, they're not flat things, you won't be able to get everything in focus. So we've done our very best to make the specimens look absolutely beautiful, but you will notice that some parts of the insects are in focus and other parts won't be, and that's just because we haven't got the depth of field on the kit that we're using. This is a common problem for entomologists. So we now have photo stacking, where we take a series of photographs through different planes and then we squish them all together to keep all the in focus parts. So all the photographs that I'm able to show you today will be really clear and crisp and show you a lot of the characters that you need to know. So these are all flies. They're all beautiful. I could just sit here and look at the photos for the rest of the evening. We're going to move on. We are going to pause just for a moment though. You might have spotted this fly in the bottom left-hand corner of my last slide. And this is a current passion of mine. So one of the problems as an entomologist, like I said earlier, is that there's so many insects to choose from. It's really hard to pick one. So I have a tendency to sort of cycle around depending on which thing is nearest to me. I am going to admit I'm always distracted by shiny things and by fluffy things. This one being a beautiful fluffy bee fly. Which is my current passion in the flies. Bee flies are, you'll see some later, they're very cute, very fluffy. They identify, one of the characters that you use for identification for them actually is this long rigid proboscis that they have here. As adults, they are nectar feeders. The larvae are parasitic though. They live in nests of Hymenoptera, so bees in particular. We do have a few species around at this time of the year in the UK, just about emerging. So bee fly watch is a big thing. And you may hear me squealing about this on Twitter later because it's time to go out into the garden and look for those sunshine spots and see a bee fly. But can we, now we've had a moment just to appreciate, I think this thing is absolutely beautiful. Existing in a world where that exists makes me very happy. We're going to do a quick bit of morphology on flies though. One thing that I think is really useful for me to say at this point in time, especially with this photo that you can see in front of you, is that you're looking at museum specimens. So all of the pictures that I've shown you pretty much so far have been of insects that are dead and in collections. When entomologists collect specimens in the field, they take them back, they have to put them under a microscope and they have to do identifications that way. Most of them are very tiny and you're looking at even smaller characters. So you really need high magnification to be able to determine what species are. But one of the things that we do is we prepare the specimens so that we can see those characters. So on this specimen, you can see that the wings have been put out flat, the legs have been pulled forwards. And this is so that we can see characters on the side for Diptera. They've often got quite an arrangement of hairs, for example, on the side of the sternum that's really important. And we do this for all insects. So all of these are actually in a slightly unnatural presentation as a result. But it's interesting that we've actually absorbed this into our collective cultural sense. If you ask any small child to draw you a butterfly, they will draw you a nice flat butterfly, and that's because that's what butterflies look like. But if you've ever seen them in real life when they're flying around and they're alive, you'll notice they don't present like that at all. So it is a little bit weird when you see museum specimens, but that just bear that in mind, that this is a sort of unnatural arrangement. So if you're drawing from real life, they will look different. The other great thing, though, that I need to mention at this point in time is that insects are symmetrical. So you have the same on both sides, unless you've lost a limb. This one doesn't look exactly the same because of the way it's been mounted. It's not perfect, but it does mean that if you are drawing insects, that you can just draw one side if you really want to, and then you can use a piece of tracing paper and flip it over and draw the other side that way. That might help some of you speed up a bit later on. It's useful to know, especially if you're doing drawings from images, where you're doing tracing or something to get outlines like that. It's a really nice way of doing it. So I'm going to give you some basic morphology. I'm not going to, hopefully with my tone setter earlier, you'll know roughly where I'm aiming for this. It is absolutely okay to hum along to this to the tune of heads, shoulders, knees and toes, for those of you that know it. So for insects, important things to know. They're three segmented. So they have three major segments in the body, which are then composed of smaller segments themselves. But the areas that you need to know about are the head, the thorax, and the abdomen. So those are the three areas. Hopefully you can see there's a neat division on this fly between the head. This is where its little neck is to join it onto the thorax. Underneath this is the scutellum, which is not a piece of the body that I've labelled up later for you, but it's quite nice to know. It's a big triangular piece and it's nice and obvious that you can spot. Under there is the connection, so that the abdomen down here, which contains all the digestive bits and the reproductive bits, is attached to the body. The other thing that's worth mentioning about insects at this point is that they have 6 legs. They're hexapods, so that's another defining characteristic of the group. They have 6 legs attached to their body. So you've got head, thorax, abdomen humming along with the rest of the tune. We then have eyes, for which for Diptera are often quite large, they're quite prominent. There are many groups where you can actually sex them based on whether the eyes touch in the middle at the top or not, bee flies being one of those great groups, in that the males have eyes that touch or very almost touch at the top of the head, whereas females don't. They have an obvious gap between the tops of their eyes. You've then got antennae up here. These are rather hidden in the CT that are on the front of the face. Flies tend to have very small antennae. It's not true, of course, because as I've already said, there is an exception to every rule. But on the whole, if you are doing sort of a casual glance at a fly, you are unlikely to be able to immediately spot the antennae. It's one of the characters that you can use for splitting them out from Hymenoptera. So a lot of Diptera will mimic Hymenoptera, in that they will try and pretend that they have a sting, like a lot of the bees and wasps do. So they go for that kind of black and yellow coloration, that banded pattern. You'll see it in some of the pictures a bit later on, I should think. But they have really tiny antennae, whereas Hymenoptera don't. They tend to have quite prominent, very easy to spot antennae off the front of their faces. So that's one of the nice, easy ways that you can split the two groups, because those are the ones that are most likely to get confused, actually. After antennae, you have wing. There's 2 of those. So Diptera means di, 2, terra, wing. So literally in the name. 2 wings. The second pair of wings for Diptera have evolved to become something completely different. So flies have their 4 wings, the front pair nearest the head. They don't have their hind wings. Instead, those have become holters. Now, this is one of the key characteristics for the group. If you can see holters, it has to be a fly. It can't be anything else. So if you're struggling with antennae at the front of the face, then checking for numbers of pairs of wings is really important. So with Hymenoptera, they have 2 pairs of membranous wings. They will not have holters. Now, the trick with Hymenoptera is they quite often have like little hooks, and their two pairs of wings are sort of velcroed together to make one plane. But you can make out that it's still two. You can look at the venation. It does, and it has a little dink at the edge of the wing to show you where the second wing has been attached. Sometimes they split apart. You see it in different ways, but the whole tear is the thing that you're looking for. If you're ever struggling to identify things and you can spot a whole tear, has to be a fly. And they look like tiny little drumsticks. So if you look at the arrow, I'm going to point over here on the other screen so that you can see it too. I think they always look like tiny little drumsticks. Here's the attachment, and they've got this round bit at the end. Whole tears are used for precision flying. So flies, on the whole, fly very well, and they can you will have seen them actually when they're flying. They can do things like turn right angles. They're that precise in their flight. They can maintain height and speed very easily, and turn corners very sharply. Whole tears is what allows them to do this. So that is an organ, and they rotate it, not just in circles, but in a variety of different ways, and it helps them with their balance. So a lot of flies can hover, which most Hymenoptera can't. So most bees and wasps can't hover. There is always the exception to the rule, however. And this is where I got reminded the other day, because I made a dramatic statement of, Hymenoptera can't hover, and then somebody turned around and said, well, what about Anthophora plumipes, which does hover in front of flowers, just like flies do. So that was my nice, tasty reminder that there is always an exception to the rule. But on the whole, bees are sort of lower, they swoop, they move up and down, they tend to be a bit more bumbly. Bumblebees is a good way of thinking about how things fly, whereas flies are much more precise, and they will travel in straight lines and this kind of thing. And whole tears is what allows them to do that. So hang on, let me click on. I get very excited about whole tears, can you tell? We're going to move on and just look at some of these things a bit more in depth. Here's the magnificent bee fly. Here he is, and you can tell he's a boy because his eyes meet in the middle. This always is very pleasing to me. It always makes me chuckle. On this large photo over here, though, you can see here's the big eyes, and up here in a little triangular patch, you'll see 1, 2, 3 little circles, hopefully. These are the ocelli. These are primitive, they're rudimentary eyes. You'll find them on the top of the head when you can actually see the head when it's not covered in fluff, like the bee flies. They are used for detecting movement, so they don't have the same clarity as a normal fly eye. They can see quite well overall. Especially the predatory species, such as you've got this is a horsefly over here. This one has enormous eyes in comparison to its body. It's mostly made of eyeball, in fact. You've got some slightly smaller eyes over here. This granular appearance probably means that they've got slightly less good visual acuity than, say, a tabanid up here. Different antennae off the front of the faces. I've already mentioned that antennae are mostly small. They're quite difficult to see on this guy because they're folded down. They're just made of 3 pieces, long arista coming off the front here, which is this kind of antennae that you've got going on. This one's been pulled up a little bit from the face so that you can see it. You do get filamentous, so thread-like antennae, and they can be a little bit fluffy. Certainly for the Nematocera, which is considered to be a sort of basal group of the Diptera, contains things like crane flies, which hopefully you all know. These are the tipulids. They often have sort of very long thread-like antennae, quite reduced mouth parts. Sometimes they don't even have jaws. They might not feed. So that's something to look out for. Otherwise, you are looking at piercing mouth parts. So a tabanid has a short, stumpy, piercing proboscis. The females are blood feeders, so they use that to stab through skin and get to the tasty goodness below. Bee flies have a long, rigid proboscis, but they feed from flowers, so they're not stabbing into anything, but they will use it to dip down to nectar. This one over here has the more typical mouthpart arrangement, which is sort of like a sink plunger on the front. So if you've ever seen houseflies feeding, they will have this sort of retractable, squishy tube with a pad at the end, and which they slurp things up through. Much like children with a straw when they get to the bottom of a glass of milk. At least that's how it is in my head. Down here you can see that ocello patch again. You'll notice this on some of the specimens that we're going to present later. So if you were at all concerned about what that weird triangular patch is, that's what it is, and that's what should be there. You might not be able to make out the detail later, but you now can picture it in your mind when you're drawing. Moving on, sorry, this little beardy faces on flies are just brilliant. This is where I get distracted and people tell me I have to concentrate again. Talking of heads, you've had nice straightforward heads, and then you get flies that do weird stuff, which is just brilliant. So tabanids, when they're alive, this is they have banded eyes, some of them, so they look like they're wearing fancy sunglasses, which just amazing. This one on the left here is it's called an antler fly, and this is actually a projection of its cheek. So you have to imagine that it's coming out either side here. You can see its eyes here and its antennae here. So it really is just that cheek patch behind the eye. This is a sexual selection thing in this group of species. There's a set of antlerless flies that come from kind of Borneo region, Southeast Asia, that have just gone crazy on the whole cheek thing, and they use them for signaling. To say, hi, I'm this species, check me out. And there's probably a little bit of going on between the girls and the boys as well, just to say, hi, haven't I got nice cheeks? Another fly family that does something equally amusing, in my opinion, are the diopsids, sorry. These are the stalk-eyed flies. That's this photo up in the top right. So if you can just hopefully make it out, these are their eyes out here on giant stalks. There's another group of flies, they're not the only family that does this, another group of flies that has a very similar evolution, where they've got their eyes out on stalks, but they're a bit more chunky in the head department. They look more like hammerhead sharks, whereas these guys have gone really for long, thin stems, hence the name stalk eye. They will quite often sit on grass stems and their eyes are out either side. It is meant to be a sexual thing. So yes, the ladies do seem to like it when the boys' eyes are further apart. Further apart, the better. Hence, you've got to a point where you've got these just enormous projections with little eyeballs on the ends. And you should hopefully just be able to make out these little nodules here. That's the antennae. So they've moved out with the eye as part of this evolutionary process. And they always make me chuckle whenever I see them. They're just brilliant. I could just look at diet. Well, I could look at flies all day, it turns out. Moving on, thorax and legs. So I've put in some side shots so that you can see a sort of lateral process. You can have, for legs, you can have long and thin. You can have fluffy. So this is an acylid. It's a robber fly. They tend to be quite hairy generally all over. This guy's got sort of joppers made of fur, which are really rather nice. These are a predatory group family, so they have a short proboscis, which you may just be able to make out here, and they eat lots of other insects. Sorry, my microphone keeps slipping off. It's really quite awkward. Over here, you can see the side of the fly, though. So this is thorax here. It's made of 3 segments, but segment 1 and segment 3 are tiny, and the big segment is segment number 2 in the middle, and it's so huge because that's where all the flight muscles are. So the wings attach there. On the underside of the fly, you've got a pair of legs on each of those segments, so that gives you a rough indication of where they are on the fly. So you've got segment 3 at the back, there's the pair of legs, but most of this huge chunk is just the flight muscle for powering these wings and for supporting that flight. You've got nice natty legs down here. One of the things I wanted to show, which hopefully you can see, it's slightly grainy, I had to blow the photo up, really quite big, but you can see that they've got 5 tarsal segments. So fly legs are fairly straightforward in that they have 2 large segments at the top. You can make it out here. You've got 1 there, 2 there, and then 1, 2, 3, 4, 5 tarsi. So you should have 5 tarsi on your flies when you're drawing later. And the end one has 2 little claws here, and then 2 little pads made of fluff. Now that changes slightly between the different groups. They're slightly different, but for most of the flies that we've picked out later, you should just be able to make out that there are 2 claws there, and then these hairy pads. Now those pads on the underside of their feet are very densely pubescent, and it's one of the things that helps them grip. So this is another it's another nice thing about flies, that you've probably seen them. They can climb vertical surfaces, quite shiny surfaces. They have these tiny claws that latch on, but those tiny hairs also just spread out on the surface and get into any sort of tiny ridge or crack or bumpy surface and help suction the fly on, in effect, so that they can climb these vertical surfaces. Wings. Oh no, wings. There we go. I didn't want to say too much about wings. I know that dipterists get very excited about them, though, and I thought it was worth mentioning in that wing venation is quite complicated with Diptera. It can be used for identification purposes. Different families have different kind of venation patterns. So there is a sort of generic overall shape. This one on the top right, apologies. This is syrphids, those are hoverflies. This one down the bottom is tipulids, which are the crane flies. And you can see there's a big difference in the venation. Now, all these little letters and numbers around the edges are the names that are given to the veins. I'm not going to go through them, but hopefully if you can see where they kind of match up on the two different things and how they look different between different species. So venation is very important, and I've brought it up because if you wanted to do a proper scientific illustration of a species, then you would need to take this into account. It's quite important. But if you are just casually drawing, you may wish to just put the emphasis that the veins there, but you don't have to be specific. It depends on what style of drawing that you want to do. This little photo down here shows you the really nice reflective rainbow sheen that you can get off of the membranes of the wings. A little Drosophila for someone out there who I know is watching, who likes fruit flies. I'm sorry, I keep pushing the button. More wings from specimens. So you can see here you've got wings with lots of veins, wings with only a few veins, patterned wings. Here's another bee fly down here because I couldn't not. You get different kinds of patterns. In some groups, they're used for signaling, so they will flap their wings and do little dances. Again, to do that intra and interspecific signaling. So I'm this species, are you the same? I'm a girl or boy, are you the opposite? So they can actually do little dances and do this. It also acts sometimes as camouflage. So this brown one here, for example, these spotty wings blend in quite well with the background. Bee flies are just cool. That's the short on that. Another pause point, because I've obviously been enthusiastic quite a lot at you by now. This one is cycodid. It's a drain fly, and I wanted to put a picture in because not all flies have fully membranous wings. This one has hairy wings, and they're unbelievably cute. It's hairy all over, hairy antennae, hairy wings. They're called drain flies because you often find them feeding on detritus that's built up in drains. And a lot of people will think they're gross as a consequence, but actually I think they're beautiful. They're really just fantastic little things when you see them up close. They get often mistaken for a moth, and you can see why actually, but they will have holt hairs and they are under their wings. So if you can find them, you can double check that. The other thing to look for is the face will look quite different. If you're doing really close up work, you'll be able to pick that out. But the holt hairs would be the thing that told you that this was absolutely a fly and not a moth. Hopefully by now I've persuaded you that flies are exciting and cool and they're pretty and bee flies especially by this point. But I just wanted to finish on talking about some more of the kind of behaviour rather than just the morphology of flies. And I know with flies there is people instinctively dislike them, and it's understandable. I've put up some of the I want to say more horrible kinds of things about flies. We do have disease vectors up here. They are, especially mosquitoes and tsetse flies, as we've got pictured here, are quite important for spreading a number of diseases around the globe. And obviously they're itchy and they bite and they're horrible, and you go on holiday and you get covered in big red welts, and it's deeply unpleasant, and I can see why people don't like them. And then you come across flies like bot flies, for example. So you may have heard about human bot flies, but there are a number of bot flies that will parasitize on animals. The horse bot fly, for example, the larvae actually spend a great deal of their time attached to the intestines on the inside of the animal. I didn't put photos in, I didn't think anybody needed to see that. Causing internal damage, and then it's not pleasant, and they're not nice. And I know a lot of people will automatically say, but ew, flies, I don't like them. There are a lot of good things about flies though, and the bad things that they do are very minor in comparison. So it's a smaller number of species that cause us animals problems and have economic impact. But they also have a positive. There's a big thing that they do for us. All these flies around. Why should we keep them? Why should we care about biodiversity? Why should we preserve habitat types? This is one of my favourites. So the big tipulids, big crane flies that you will see, I know that I remember seeing a lot when I was a child and thinking, what on earth are they useful for? Because they just bumble around. Adults aren't particularly useful. As an adult, it's all about sex and death. But the larvae for tipulids, for example, are called their leather jackets. They have quite tough skin. They live in your lawn. People get upset because they chew your grass. But they're a huge food source. So a lot of flies, a lot of insects generally are huge food sources for other insects and other animals. So you will notice that if you have a lawn that's infested with leather jackets, you'll get a lot of birds that come down to feed, and they will dig the larvae out of the lawn. And that's a major food source for them, and it supports things such as the starlings in my back garden that love the tipulids that live in my lawn, for example. So I'm always happy to see them flying around. They are a major part of any food web, and relied upon by a lot of larger animals and organisms. We've also got, on the left, we've got calophorids, which are blowflies. That might be one that you recognise. They're a major group in cleaning up for us. So lots of flies, maggots, but they clean up a lot of poo. They clean up dead things. They eat carrion. They take away all the gross stuff that would be just piling up around our world otherwise. And they do a good job of breaking down all of those organic materials and just making them disappear. So a lot of larvae for Diptera are responsible for removing all those things that we hate most in the world. So rotting foodstuffs, dead animals, lots of feces. And we should thank them for this. They do a grand job. It's brilliant. The other major thing that they do, and we've got some syrphids on the top right here, which are hoverflies, is they're major pollinators. So there's about 555, I think, was the latest figure that I saw, different flowering plants that are pollinated by syrphids. They're really important. They're probably as important, maybe more so, depending on your point of view, than bees and wasps. They pollinate a wide variety of plants, including some of our crop plants. The most important one, and this is where I'm just going to finish, hopefully I've persuaded you that flies are great, but if you still needed something to tell you that flies are great, the final thing you should know is that these tiny little midges that we have right here are pollinators for cocoa plants. So if we didn't have them, we wouldn't have pollinated cocoa plants, which means we wouldn't have chocolate. That swayed it for me. That when I learned that fact, I was like, okay, so flies are responsible for chocolate. Thank you very much. That's all I needed to know. So these tiny little midges, that's what they do in life, and that's what they're perfect for. So hopefully by now you'll be pleased to know I'm going to stop in a moment. I've persuaded you that flies are great, that they have some interesting behaviours, some interesting biology, and that they are beautiful things in their own right. I've put some links at the bottom for some sites that I've used to put this talk together. If you do want to know more about flies, we have, certainly in the UK, we have a very active group called Diptera's Forum, who I thoroughly recommend. They're really good as a society in supporting people in their love of flies. And so you can come and join us in that section. But that's everything from me for the moment. I'm going to hand over to Chris again, and Laura, who will set us up with our flies to draw.
Those are absolutely wonderful, Zoe. Thank you so much for sharing all the wonderful things that we have about flies. Some really cute specimens there, and actually some so cute that people have been putting in the chat comments that you actually did make some people actually squeal with delight with that brain fly there. But it's time for you to get your art materials ready. So we're going to start off with a rather wonderful specimen for one of your first 2-minute challenge. So we're going to have two 2-minute challenges, followed by a 6-minute challenge. Then we're going to have a 10-minute challenge, and then finally a 15-minute challenge. So could you tell us what this specimen is, Zoe?
Yes, I can't see the picture, but I know what it is. I know what's coming. It's a robber fly. So all of the groups that you'll see tonight, I've chosen because basically they're my favourites. So this one's a robber fly. It's an acylid. They're very furry. They have the little beardy faces. You'll notice that quite big eyes on this one. These ones are predatory, and they're responsible for feeding on a lot of insects, actually. So they help keep down other insect numbers. So we need robber flies to control other insects.
Excellent. Well,
Brilliant.
grab your pens and papers, and off we go with our first specimen. Okay, we've got about 30 more seconds on that specimen, so I know it's fast, but we're almost ready to turn over. Okay, and this is our second specimen. Wonderful. We've just about finished with that specimen. That was one of our the big family, the Eulidae, possibly an unknown species, that one. But on to our next one. You've got 4 minutes for this next species, so have a go at this next one. Okay, you've got about 2 more minutes on this really beautiful, shiny little jewel. It's about 2 more minutes before we swap over. Okay, possibly time to get another piece of paper ready because we're going to follow up this beautiful little beastie with another specimen, and our next specimen is just coming up. And this specimen is a canopid fly. Okay, we're about halfway through drawing this. I hope you're drawing this fantastic canopid is going well. You can see why they're called thick-headed flies. There is one in this country actually that in Britain that parasitise hornets. So they actually insert an egg in between the plates on their abdomen, and the larvae then takes control of the hornet's brain and makes it dig its own grave and bury itself where it can incubate in safety. Okay, and now for the grand finale. So whilst we're showing these rather beautiful flies, I'll have Zoe online as well, and we'll get a chance to ask her some questions and ask her your questions. We've had some lovely ones that come in already. So we've got 15 minutes to draw these rather spectacular beauties. So Zoe, are you there?
Hello.
Hello, wonderful. So can you tell us which group of flies are this? I think I might guess, but
Yeah, I'm sure everyone's going to be majorly shocked when I tell you that they're bee flies, because I really wasn't lying when I said that they're my current obsession. Although I have to say they are a long-term favourite of mine. They just kind of peek up and down in where they are on the heap. Because they're just too cute. Look at them. I mean, they're round and they're fat and they're fluffy. I mean, what's not to love about them, really?
that's fantastic. Well, that probably answers Chantel's question. She asked if you had a chance to make a fly costume, which fly would you dress up as? So,
Ooh. Yeah, no, it would probably have to be a bee fly, just on the basis that when things are allowed and we're back to being face to face and things, I feel like a giant bee fly costume would be really huggable, and that'd just be really nice to walk around making people cheery and handing out bee fly hugs.
wonderful. We've got some nice questions here about bee flies, actually. Hannah asks, are they called bee flies because they mimic the morphology and the fuzz, or because they parasitize bees and other hymenoptera?
Well, so it's a good question, and it's both. So bee flies get their name because they not only look like bees, in that they're very fluffy. They look quite similar to bumblebees. A lot of them, at least from a distance. Most of them, well, all of them, are parasitic on solitary bees. So the color, the patination, and body shape is meant to sort of, I think, give a general appearance of the things that they're trying to parasitize, maybe make them not so obvious. Because as a group, it's quite fun. I love the life history of these, because you look at them and they're cute and fluffy, and then you find out what they do. So the female bee fly actually will duck down onto a surface and collect up dust and little bits of sand on the tip of her abdomen, which she uses to coat her eggs. So she then takes those eggs, she hovers somewhere near a bee nest, and she will flick her egg into the solitary bee nest. It's thought that the dust might help sort of maybe camouflage the egg, or possibly add a bit of weight to it so that they can get a more precise aim, because obviously that's quite hard. If you think about it, you're hovering over a hole and trying to flick a tiny egg down it. The egg then hatches, and the larvae parasitize the bee's larvae, and they'll actually eat them up. Which is the less nice bit about bee flies. But then obviously they emerge. But you only get bee flies when you've got good, healthy populations of bees. So they've coexisted for a long time. So you wouldn't ever be in a position where bee flies were sort of detrimental to bees, at least not in a grand scale, where they were going to cause anything like population loss or anything like that.
Wonderful. And actually, talking about their fuzziness, Megan and Lance asked, what's the purpose of all those little hairs on flies, and why are some so fluffy?
So I think with the bee flies, it's camouflage. I'm not sure overall for the different groups. Obviously, we saw a drainfly earlier, which was just ridiculously fluffy, and I'm not sure as to the purposes of that fluff. I have to be honest. It might have something to do with kind of habitat, whether they're in a sort of warmer or cooler area, possibly. That's one of the other things that can affect hairiness on insects. But it has a wide variety of uses, and in some cases, you sometimes get fluffy things just because it's not a negative or a positive. It's evolved and it's a thing they have. You do get these signaling things as well, though, as I mentioned earlier. So it might be that there's a sexual signaling going on, camouflage, or in the case of some things, a sort of fake warning coloration. So lots of reasons, I guess, is what I'm saying, really, as to why they might be fluffy. For bee flies, it's almost certainly because they're mimicking Hymenoptera to some extent.
So, Zoe, that brings me to another question, actually. Katerina's just asked, why do bumblebees have fur or hair and wasps don't?
So they do. Wasps do have fur or hair, but they have very short fur, very So it's so they're not fluffy in the same way as bumblebee was. To be honest, though, I don't know much about Hymenoptera, so I'm going to go out on a limb, which inevitably means I'm going to get it wrong, and somebody will correct me, which is the best thing about entomology, is that there's always somebody that knows. But let's have a think. So bumblebees are usually ground-dwelling. They live in nests. Maybe it's something to do with keeping them warm in that kind of environment or that habitat. They tend to live in either solitary or very small colonies. So it's possibly something to do with that. I don't know. Hymenoptera is a group that I've never studied, I should say. So this whole thing about being an entomologist and not being able to do kind of overarching statements is, with a million species, people tend to be quite niche in what they study. So they will pick a group and then work their way down to it. And I've never looked after the Hymenoptera collections here, so I've not had good reason to learn much about them, I'm afraid. I know I like bumblebees because they're fat and fuzzy. So
actually brings me on to Samantha's question. So Samantha asked, "What's the best insect textbook these days? Is it still Guller and Cranston?" So she's obviously wants to find out a little bit more, in a bit more detail with each spider. So what would you say was?
Oh yeah, it's. I've just disappeared. I think we've lost a little bit of connection, but hopefully you can all still hear me. So there is a wide range of books and resources available. It depends on how much detail you want on a group. So for beginners books, right at the top of the chain, I often recommend things like there's an old Dorian Kingsley book actually, which is great, just lays out all the orders and shows you a lot of the characters. The Collins Field Guide to Insects of I think it's Britain and Northern Europe is a very good starter piece, and then depending on which order you're looking at, you would work your way down. One of the other, I'm going to see if I have it on my shelf, almost certainly not because I've probably taken it home. Yes, so our ex-assistant curator, George McGavin, who some of you may know of TV fame, has also done a nice introductory text to insects that I often recommend as well. So
is that Essential Entomology, that one?
I believe it is, yes.
That's one of my favourites there.
Yeah, I can picture it on my bookshelf at home now.
That's wonderful. Now, moving on to other bits of the fly's anatomy, I did say I would ask this question, and Eleanor asked, how do flies protect their eyes without eyelids? And Claire asked, do they all have compound eyes?
They do all have compound eyes, yes, and they have quite good visual acuity generally. They clean their eyes a lot is the answer. So you may see this if you're watching live flies, even with houseflies actually, you'll see them, they'll bring their forelegs up in front of their faces and you'll see them like wiping at their eyes because they do get dust and grit. You may have seen it even on some of the specimens. Certainly one of the bee fly photos that I showed earlier, you can see pollen all stuck in its fur around its face. So they do get dirty just in general everyday life. So they will actively clean themselves using their forelegs. And in some cases, they sometimes have different insects. They have sometimes notches or little combs along their fronts of their legs, like rows of setae and hairs that they can use to actually, clean themselves off and get all the dust and grit off.
Wonderful. Following up with bee flies, Sarah asks, do bee flies hatch out of the ground? Because she says she thinks she has lots in her Oxford garden.
Well, so yes, in that they are parasitizing solitary bees, and solitary bees dig holes in the ground and have nests, usually. Not all of them, but a majority of them will live in holes in the ground. So yes, you will have bee flies emerge from the ground as a result. They like, so a nice thing to do at the moment, so we've just entered Bee Fly Watch in the UK. So the earliest record in a year is February 17th, we're past that date now. Every year, normally entomologists have a bit of a competition to see who can be the first person to spot a bee fly. So there's a really active recording scheme for this group, actually. So you can use iRecord, or there is a bee fly web page for the UK. So I would encourage you, if you think you've got bee flies in your garden, if you think you've seen one, to go and enter that record, because I don't think the crown's been taken yet this year. So you can have the smug points for spotting the first bee fly of the year if you're quick.
I thought better remind people they've got about 4 minutes left to finish these beautiful specimens, drawing these specimens or painting or whatever medium they're using. Got a question from Eileen while we're doing that, Zoe. Eileen asks, what are the wings made out of, and why are they mostly see-through?
Oh, so they are membranous wings, but they are hardened. There's no fluid in them. Like most insects, they have to inflate their wings after pupation and then dry them out. So it's a crispy membrane. I believe it's got some level of chitin in it in much the same way as their exoskeleton does. They vary between pattern and membranous. I think most probably have clear wings. I don't know if there's any particular significance to that, though, I'm afraid. I do know that the ones that have patterns, like I mentioned earlier, can use them for signalling. And they, you get some groups that do little dances and they flick their wings around. There may even be an element of sort of surprise as well. So when you have patterned wings and you flick them, that change in color, light intensity, movement as pattern moves can be a bit disruptive to any kind of predators that might be nearby. So if it breaks up your visual, your outline, makes you harder to spot or makes you harder to target, then that can help prevent you from being predated on. So that's one of the things that you see coloured wings being useful. And actually metallic colours do exactly the same thing. So that fly that we saw earlier, that was just all metallic, beautiful blues and greens. As they fly and the light reflects and refracts off of their exoskeleton, it's almost kind of twinkly. So if you were a bird, for example, that was looking to eat this big fat shiny thing that you see flying around, it seems a bit counterintuitive because to us we'd go, shiny, I can see that. But as it moves, actually, it makes it very difficult to track where it is visually. So metallic colours are actually a form of camouflage in their own right in that respect.
Now, I know that birds see in ultraviolet, which brings me to Katerina's next question, which is do flies see in ultraviolet? So do they see the world in different colours to us, and maybe is that something to do with the wing?
That's a very good question, and I don't know the answer to it.
Oh, fantastic. Well, that's what we like in science. Questions we can't answer. That's what science is all about. That's what's beautiful.
I mean, visual acuity in insects, like how they see the world, is a massive subject, and I think we've still got so much to research on it. And I'm sure there are people out there who do know what's going on and do the research. It's not a subject that I've delved into a lot. Even things like flight mechanics, when you're talking about insects when they're so small, air is effectively a fluid to them, how they visualize the world, and then how we translate that so that we can understand how they visualize the world. So one of the things that you'll quite often see with fly eyes is that idea that they've got like hundreds of little pictures somehow from all of the from the different sections within their eye. I'm not sure that's how we perceive that they perceive the world. I'm really not sure that that's true. So yes, luckily we've got a great researcher on staff who's looking at exactly these kinds of things. So
I think she might be watching tonight. But
yeah.
looks like we've come to the end of tonight's session, Zoe. So thank you very much once again for such a wonderful and inspiring talk, and hopefully we've inspired you out there not just to create some beautiful art tools, but also to love some of the most accessible and beautiful of the biodiversity that surrounds us and is around at all times of year as well, all the way around the world. We're going to finish up now, but do share your pictures with us on social media, on Twitter, and our hashtag is @morethan_a_dodo, because we'd love to see some of the artwork that you're doing. And obviously we've got more events coming up. There's a link to those in the invitation you received for this, but on International Women's Day we have Dr. Amy Dickman, who's part of the Pride Alliance, who looks after lions in Africa with African women out there, and a bunch of very committed female zoologists. And in 2 weeks' time, if you've enjoyed this event, we have another Drawn to Nature event, which is our own Dr. Hilary Ketchum, and you're going to get a chance to find out about and draw plesiosaurs. But thank you very much for joining us all tonight. Thank you once again, Zoe, and we hope to see you soon. Thank you.
Thank you.